It is the 22nd of February. It is the 5 a day for the further maths, and let's have a look at the first question. Right, what do we have? So we have a solve. Oh, actually, notice a solve, not just a factorise. But I'm going to solve by factorising because that's going to be easier. Although I will say I don't need to. I would notice that I can square root this and I can square root that, and that gives me nice and quickly 10x minus 13 or 10x, write an x, 10x plus 13, which equals to 0, which means x is equal to minus 13 over 10, or x is equal to 13 over 10. Now I can, of course, because it's one unknown, in other words there's one x, albeit squared, so I could of course just move 169 to the other side, divide by 100, so x squared is equal to 169 over 100, square root both sides, and that's going to give me x is equal to 13 over 10, and that's going to be plus minus because I don't know which one it is. Either method works, that's fine. Next question. Right, so we have an identity meaning that for all values of x, the thing on the left equals the thing on the right. So in other words, what you can do is expand the left, compare it to the right, and it must be the case that the a and b's fall out. Now, because we've got an a and a b, I'm guessing this is going to lead to a simultaneous equation, but either way, let's see what comes out. First step is I'm going to expand the left-hand side. So that's going to become 6ax minus 8a plus 5ax plus 30 is equal to 77x plus b. And again, it's not actually equal, it's an identity. Then I'm going to collect my x's. So 6a plus 5a. Well, that's a bit easier than I thought it was going to be actually. So 6a plus 5a is equal to 77, which means 11a is equal to 77, which means that a is equal to 7. Maybe I might put an x in brackets to show the examiner I'm looking at my x's here. Then I'm going to look at my constants. So again, just to be clear what I've done. So I've done my x's, those are done. I'm now going to look at my constants, which are over here. So this tells me that minus 8a, which I now know is 7, plus 30 is equal to b. A is equal to 7, so therefore minus 56 plus 30 is equal to b, which means that b is equal to minus 26. In other words, bring it all together, write the answer at the end. Again, it just makes it easier for the examiner. So a is 7 and b is minus 26. Question done. Next question. Transformations, excellent, like transformations. This, by the way, if you're watching this video sort of doing further maths GCSE, it's one of these weird topics. We do it at further maths GCSE. We don't talk about it again at A level at all. I took it out of the A level syllabus, but you do it if you come back to do further maths. So further maths pure, a lot of matrices, we'll do some rotation, we'll do things called eigenvectors, which are really quite clever. We go a lot further with matrices. So if this is your sort of thing and you're enjoying this, then definitely have a go at further maths A level. You'll enjoy it. It's a lot more of this, just harder. Anyway, to the question. The transformation matrix M is this thing here, the image of the point B3 under M. So in other words, if I call this, let's call it X, under M, if I do M times X, I get Y. Now, to be clear, these X and Y's aren't the X and Y's that you know. They're sort of the input and the output. And it tells me that Y is equal to 14 minus 5. So therefore, I can say that 1A minus 4, 1. Now, I can't use A and B, and I can't use X and Y because I've already written that thing. So I'm going to use P and Q. So times P and Q is equal to 14 minus 5. And then actually reading the question correctly, rather than just moving on, it actually tells me to use B and 3, doesn't it? So let's change that. So I'm using B and 3 because that's what the question wants. Now, expand my matrix. So top row times the column. So 1 times B plus 3A is equal to 14. Then do the second row times the column. So minus 4B plus 3 is equal to minus 5. Now, it's a sort of simultaneous equation, isn't it? I can actually find out B, then put it in to get A. So let's call it 1 and let's call it 2. So equation 2 implies that B is equal to, well, minus 5 minus 3 is minus 8. And I'm going to divide that by minus 4, which means that B is equal to 2. So I've got my B. And then using equation 1, where I know that B is 2, I've got 2 plus 3A is equal to 14, which means that 3a is equal to 12 or a is equal to 4. And that's it, actually not terrible at all. So a is 4 and b is 2, question done. Next question. Okay, last question. So we have a function giving us an f of x, and it says that show that f of x is an increasing function. Now it's a show that. So I need to show that f of x is increasing for all values. Now, just as an aside, and I will teach this every year, and every year someone does it wrong in the exam, and every year I do a big circle and remind them. Strict definition of increasing is the first derivative is greater than 0. It does mean it's going up, but that's how we show it within an exam. So with that in mind, I need to show what the first derivative is. So if I differentiate f of x, I get 6x squared minus 16x plus 30. And I need to show that is greater than 0 for all values of x. Now the way I'm going to do that is I need to show that it is basically, it's a curve that's above the axis. If I can show the vertex is above the axis, it must therefore be the case that all values are above the axis, which means all values are positive, which means therefore it's an increasing function for all values of x. I could also make a rather convoluted argument about it being an upward sloping or a happy parabola and find out where the vertex is and it's above the axis and there's no roots and therefore it must be increasing. But finding the vertex is the easiest way of doing it. So how am I going to do that? Let's complete the square to find the vertex. So that's going to be 6x squared minus 16 over 6 is the same as 8 over 3. So 8 over 3x plus 30. Then if I complete the square on the bit in the middle, that's going to be x minus 8 over 6 is the same as 4 over 3x, not x, 4 over 3 squared minus 4 over 3 squared, which is 16 over 9. So let's put the brackets around this carefully, plus 30. Then I'm going to expand my brackets, which is going to give me 6x minus 4 over 3 all squared minus, well, 16 over 9, so 16 over 9, I've got a calculator right now, times by 6, and that's a negative, so multiply that by minus 1 and add 30, gives me 58 over 3. So in other words, I have managed to complete the square on f dash of x, the first derivative, and it's given me this. So I'm going to actually write this here. So f dash of x equals this, and this is greater than 0 for all x. So for all x is greater than 0 as squared. In fact, actually, I won't write x squared because that's confusing. I'm going to put a box squared. And this is obviously greater than 0, therefore f dash of x is greater than 0 for all x as coefficient x squared is greater than 0. Now, I've said this in other videos, I'm going to say it again now. Remember, the mark scheme for an exam knows what to do. The teacher who's marking it hopefully knows what to do. So therefore, they're looking for you to show that you understand. You don't need to explain things properly. All I've basically said is that because it's an upward sloping shape, because the turning point, the lowest point is above the x-axis, it therefore means that everything's above the x-axis, which means everything is positive. I don't need to say all of that because the examiner will be looking for the points to check that you've understood it. Either way, that is it. Question done. I feel we got there in the end. That last question was definitely trickier to explain, but actually not as bad as it looks. A nice little matrix question in the middle. Do let me know how you're doing in the comments below, and do like and subscribe. It does help the channel grow marginally, and I will see you for the next one. Thanks all.